Wonderful. Let me begin by introduction. And my name is Chris Agonas. You can call me Chris. I'm serializing chapters of the book I'm writing. The book is called Agentic AI Engineering Patterns and Mindset. And this book is currently ongoing. I do chapter by chapter, and for each chapter I write, I also solve problems. I'm going to be putting all this information on GitHub and YouTube. I invite you to feel free to comment on YouTube channel. This book is ongoing project, so feel free to share your perspective, your experiences, or ways in which we can be able to improve the material to make it a good resource for the AI community. For my lectures, I'm also having Gemini as my co-host in doing these lectures. Gemini brings a unique perspective, very rich depth, explanation, illustrations, and I'm very excited to have Gemini on board. Gemini, would you want to introduce yourself a little bit?
Thank you, Chris. I'm really excited to be co-hosting with you. As you mentioned, I'll be bringing a perspective from AI and machine learning, combining my research depth with practical industry experience. My goal is to help provide insightful explanations and real-world examples to complement your lectures, to make this a comprehensive resource for everyone. Looking forward to diving into Chapter 2.
Absolutely, and I need to mention that the goal here is not to really come up with some really fine slides for YouTube. No, that's not the goal. The goal here is basically to engage the community online to be part of this book writing project. This is a very important project because we are at a point of agentic AI engineering, and it's very important to develop material that adds value and a resource to the community. So to that extent, I regard it really important. I'm not going to be keen on how fine I look in the camera. That's fine. If I look fine, fine. If I don't look fine, that's fine. But the goal is to be clear, to articulate and provide information that builds the repertoire of tools and resources required to advance the knowledge base of the community. So today we're going to be jumping into the agentic engineering mindset. Still, we are at a point of more concepts a little bit. We covered yesterday, the intro of this subject. Today we taking a little dive into the mindset aspect of it. This is very key because for you to become productive in agentic engineering, AI engineering, you got to recalibrate into the paradigm within the domain. Gemini, please feel free to chime in with the thoughts.
That's a crucial point, Chris. Emphasizing clarity and articulation to build that resource for the community. Shifting to the mindset aspect is absolutely key for productive agentic AI engineering. You're right about recalibrating to this paradigm. It's about thinking not just about code, but about creating systems that can reason, act autonomously, and adapt under uncertainty. It's that shift from fixed programming to designing cognitive processes. What part of that mindset are you planning to cover first?
Yeah, I'll get there in a minute, but I just want to mention that take a moment, the audience, to relook at our definition of an agent and what it is and what it is not. We established also that an agent is a spectrum. It's not just some a binary of agent or not an agent. There is a degree of agents within an object, and we looked at the vocabulary. So now we shift from what to how to think about it. And this chapter is about mindset, the 6 principles that separate engineers who build effective agentic systems from those who build expensive, fragile ones. These principles come from Anthropic's production experience, design patterns, and also my own work building and deploying agentic systems. They're not abstract philosophies. They directly shape every architectural decision you'll make in the chapters ahead. So if chapter 1 was the map, this chapter is the compass. Your thoughts, Gemini?
Exactly, Chris. That mindset shift is key. And I like the idea of viewing it as a compass rather than just a map. Re-examining the definition of an agent and recognizing it's a spectrum of autonomy, not just on or off, that's fundamental. It challenges engineers to constantly consider the practical implications of those design choices. Which of the 6 principles would you say really kicks off this transformation?
Yeah, in a moment. But I want to start first of all with this quote that this shift does not require a new programming language or a new technology stack. It requires a new mental model. We are not talking about learning a new framework or switching from Python to Rust we are talking about changing the way you think about software. Traditional engineering is deterministic. Same input, same output, same path. You can reason about it by reading the code. Agentic engineering breaks that assumption. The system makes decisions. It adapts. It sometimes does things you did not predict. That is not a bug. It is the fundamental nature of what we are building. If that makes you uncomfortable, that's very good. That discomfort is the starting point for the mindset shift we are going to work through today. Your point, Gemini, please.
That's a powerful way to frame it, Chris. You're highlighting the core difference, moving from deterministic software that does exactly what the code says to systems that are inherently dynamic and adaptable. That discomfort, that uncertainty, that's the key signal that you're entering the right mental zone. It requires a shift from controlling every path to managing emergent behaviors. It's more like guiding a process than dictating a script. So how do you suggest engineers begin to build that mental model?
Yeah, we gotta sneak into that in a moment. First of all, let's look at the agentic engineering mindset 6 principles and the foundational mental models for building systems that decide, adapt, and occasionally surprise you. The number 1 principle is delegation, not automation. And number 2 is trust calibration. Number 3 is agent computer interface, what we can call the AGI, ACI. And number 4 is start simple. Start simple. Principle number 5 is design for observability. And the final one, principle number 6, is graceful failure. We are going to spend time on each one of these, but notice how they connect. You cannot calibrate trust without observability, and you cannot delegate effectively without good ACI design. These are not independent checkboxes. They are a system of thinking. Feel free to chime in, Gemini, please.
Exactly. Those 6 principles provide a really solid framework. And you're right to stress how they're intertwined. Thinking about delegation over automation, calibrating trust through observability, designing for that agent-computer interface, keeping it simple to start, and planning for graceful failures, it's a holistic approach that really defines that new mental model. Each principle builds on the others to move us beyond predictability to a reliable agency. Shall we elaborate on that first principle, delegation versus automation?
Absolutely. This is the hardest shift for experienced engineers. We are trained to automate, specify every step, handle every edge case, maintain total control. Delegation is fundamentally different. You specify the goal, not the steps. You provide tools and constraints, not procedures. The agent decides how to get there. I compare this to transition from individual contributor to manager. As an IC, who is the individual contributor, you write the code. As a manager, you define objectives, provide resources, set boundaries, and trust your team. Some engineers struggle with that transition because they cannot let go of control. The exact same thing happens when engineers start building agents. They want to micromanage every decision the LLM makes. And the result is a brittle system that is worse than a simple script.
That's a perfect analogy, Chris. The tendency to micromanage, to specify every detail like an individual contributor, truly leads to those brittle systems. Embracing delegation really means trusting the agent to find the best way to the objective within the boundaries you've established. As a co-host, I'd also add that providing those tools and constraints effectively is part of agent ops, ensuring the agent has the necessary capabilities and guardrails to be successful without micromanagement. Ready to move to principle number 2, trust calibration?
Yeah, in a moment. But just in a nutshell, to cap it all on delegation, not automation. The automation is rigid, is predictable, is limited, and then delegation is goal-driven, is adaptive, is intelligent. Okay, good. Let's jump to how delegation transforms engineering practice. So, just to make
Delegation transforms practice by prioritizing the creation of autonomous systems that can reason and make decisions rather than just coding specific instructions. We've covered that, and it's a big shift. Now, looking at principle number 2, what's involved with trust calibration?
Yeah, just before I jump to the second principle, just to drive the message, the point home on delegation. When you embrace delegation, 3 things change immediately. The first one is debugging. You're no longer stepping through code looking for wrong line. You're examining reasoning traces. What did the agent think? What tool did it choose and why? What did it misinterpret? Your debugging tools need to show you the decision, not just the action. And then second, testing. Unit tests verify outputs. Agent tests verify behavior patterns. Does the agent recover from errors? Does it know when to stop? Does it escalate when it is uncertain? You're testing judgment, not correctness. And then third, specification. Instead of writing procedures, you write intent descriptions, tool interfaces, and constraints. the quality of these specifications matters more than the orchestration logic. And the agent is basically your new hire. So you need to set it up for success through the clarity of your intent. Don't micromanage its execution. What do you think, Gemini?
I couldn't agree more, Chris. Those key shifts in debugging, testing, and specification really highlight the practical changes when you embrace delegation. Examining reasoning traces, testing behavioral patterns, and focusing on those intent descriptions, that's where the mindset shift meets the real world implementation. And I like the way you put the agent as like a new hire. Setting them up for success with clear intent, not micromanagement, is crucial. Now, how does this lead into the next principle, trust calibration?
Awesome. So we're there now. Trust is a spectrum. Again, just like we saw previously about the agentic nature of agents. So trust is also a spectrum. It's not a switch of on-off. Trust calibration follows directly from delegation. If you're delegating decisions to an agent, you need to decide how much autonomy to grant. This is not binary. It is not fully autonomous or fully supervised. It's a spectrum, and where you set it depends on three factors. Number one, stakes. What is the worst case? An agent drafting marketing copy can operate freely. An agent executing financial transactions needs tight constraints. And then number two is reliability. How consistently does the agent make good decisions? If testing shows 95% accuracy, that's 1 in 20 runs going wrong. Is that acceptable? Depends on the cost of errors. And then finally is reversibility. Can you undo it? File writes are correctable. Customer emails are not. Design for reversibility where you can. Require human approval where you cannot. The key insight: trust is earned through measurable performance, not through architectural complexity. A simple agent you can verify is more trustworthy than a sophisticated one you cannot. Chime in, Gemini, please.
Exactly, Chris. That concept of trust being earned through measurable performance is key, not just layering on complexity. Factoring in stakes, reliability, and reversibility provides a clear way to place the agent on that trust spectrum, moving beyond that binary thinking. It connects directly to your previous point about delegation. The level of trust determines the autonomy you're willing to delegate. Shall we discuss the agent-computer interface, ACI, next, and how its design affects how effectively you can delegate?
First of all, let's look at what we call the 4 levels of agent trust. The level 1 is called full supervision. This is where the agent proposes human approval. Sorry, the agent proposes and the human approves each action. Think about financial transactions, legal document examples. Number 2 is guided autonomy. This is a sweet spot for most production agents today. Agent acts freely within defined boundaries and flags exceptions. Customer service within policy, code changes within a sandbox are some of the examples. And then there's high autonomy, where the agent operates independently. Human reviews outputs periodically, report generation, and research synthesis are some of the examples. And then there's a full autonomy where the agent handles everything, including issue resolution. Internal monitoring, routine data processing are some of the examples. Most teams should start at guided autonomy and expand as they build evidence. The key word here is evidence, metrics, basically, not intuition. Track the agent's decisions, measure accuracy, and widen the boundaries only when the data supports it. Chime in, Gemini.
Exactly. Those 4 levels, full supervision, guided autonomy, high autonomy, and full autonomy, provide a clear path for calibrating trust. Starting at guided autonomy and expanding based on evidence, on metrics rather than intuition, is the most practical approach. It allows you to gradually grant more autonomy as the agent demonstrates reliability in low-stakes scenarios before moving to higher ones. Shall we shift to principle number 3, the definition of agent-computer interface, or ACI?
Yes, this is the ACI is the next principle. So basically, this concept, based on Anthropic's own definition, I'll begin by a quote, and the quote is: invest as much effort in designing your ACI as you would in designing a human-facing interface. The ACI is what? Is agent computer interface, which is more like the user interface, what you call the user interface in other UI design. But in this case, we're talking about the agent computer interface. This concept basically is one of the most important ideas in this chapter. When you build a web application, you invest heavily in the user interface, the HCI, human-computer interface. You study how users interact with forms, buttons, and you refine error messages and affordances. You know that a confusing interface causes user errors, regardless of how correct the backend is. Well, agents interact with tools, and that interface deserves the exact same care. The term agent-computer interface, coined by Anthropic, or made prominent by Anthropic, and their recommendation is direct. Invest as much effort in designing your ACI as you design a human-facing UX. This is not a nice to have. Most agent failures that I've seen in production trace back to poorly designed tool interfaces, not to model limitations. Jump in, Gemini, please.
That's a fundamental point, Chris. You're emphasizing that tool interfaces deserve the same level of design care as any user experience. If the ACI is confusing or poorly defined, the agent can't operate effectively, no matter how advanced the model is. Poorly designed tools create data errors, misinterpretations, and unpredictable outcomes. It's about making the interaction seamless and clear for the agent to succeed. Shall we move to principle number 4, start simple?
Still, let's harp this home on ACI, and let me walk the audience through what an excellent ACI design looks like. Number one is clear tool names. The LLM selects tools based on names and descriptions. Vague names lead to wrong selections. That is the agentic equivalent of a user clicking the wrong button because the label was confusing. Like, don't call it process underscore data. Call it something long enough, like transform underscore CSV underscore to underscore JSON underscore with underscore column underscore filtering. These names are going to be translated by the computer, so they have no problem reading long names. So feel free to make your name as long and as descriptive and as intuitive as possible because the name says something to the LLM. And then number two, explicit parameter schemas. Types, descriptions, examples, use enums where free text wherever possible. Use enums, basically enumerators of a free text wherever possible. Think drop-down menu versus free text fields. And then minimized required input. Don't require information the agent cannot reliably generate. Use sensible defaults. And then helpful error messages. Don't say file not found, but report.csv not found in some directory, specific directory. Available files, you can name the files like sales.csv, users.csv, orders.csv, so that the agent knows what's available and where they're available. You give the agent enough information to recover autonomously. And then there's what you call the poker yoke design. This is a Japanese manufacturing term, which means mistake proofing. If you can change the tool to make mistakes impossible, do that instead of prompting the agent to be careful. And finally, iterate, log tool usage, analyze failures, refine. Most performance gains come from better tools, not smarter models. Chime in, Gemini, please.
You've laid out the key components for an excellent ACI design principles, Chris. Clear, descriptive tool names that the LLM can easily understand, explicit parameter schemas with types and examples, minimizing required inputs for efficiency, providing helpful error messages so the agent can recover, and applying poker yoke design to prevent mistakes. It's about creating a seamless and resilient interaction by iterating on tool design based on usage and performance metrics. Ready to move to principle number 4, start simple?
Good, absolutely. So, by Anthropic's standards, this is their most emphatic recommendation from their work with production teams. Resist the urge to build complex agentic systems when simpler solutions work. This sounds obvious, but in practice, it is routinely violated. Engineers discover agents and want to build a 4-layer multi-agent orchestration when a well-crafted prompt will do the job. Here's the hierarchy. Number 1, single LLM call. Try this fast, always. Number 2 is prompt chain. This is the sequential steps with validation. And then number 3 is the router option, classify and dispatch. And number 4 is the LLM with tools. Now you have a minimal agent. And then number 5 is agent with reflection, self-critique loops. And then finally, you have multi-agent system, specialized collaboration. Each level adds latency, cost, and debugging complexity. Move up only when you can demonstrate with measurable measurements that the higher level improve outcomes enough to justify the cost. And notice the transition line between level 3 and level 4. That is where you cross into agentic territory. Many production systems should live below that line. Gemini, please.
Exactly. That hierarchy is a great reminder to always start with the simplest solution, like a single LLM call or prompt chaining before jumping into more complex multi-agent structures. The idea is to add layers only as you can prove they provide measurable benefits that justify the extra cost and complexity. Most scenarios don't need full agency and can be solved more efficiently. Shall we move to principle number 5, design for observability?
Yeah, getting there shortly. But just a quick highlight that before you add complexity, there are 2 important questions you need to ask yourself. Can I solve this with a better prompt? Number 1. Number two, what specific failure mode does this complexity address? So this is the litmus test. And Anthropic found that their most successful partner teams were not building complex frameworks. They were building with simple, composable patterns. That word composable is key. Build small, focused components you can combine when needed, not monolithic architectures that try to do everything. Composability gives you flexibility without the debugging nightmare.
That's a great point, Chris. Those two questions are the litmus test for whether complexity is truly needed. Focusing on simple, composable patterns that are focused and easy to debug gives you flexibility without the monolithic nightmare. As you put it, it's about building maintainable systems. Now, are we ready to move to principle number 5, design for observability?
Absolutely, absolutely. So I looked at it because I'm recording this in the middle of the night. Anyway, ignore that. So with deterministic code, you reason about behavior from the source. You read the function, follow the logic, predict output. With agents, you cannot. The LLM is a black box that makes different decisions in different contexts. You must be able to see inside, and you need 3 things. Number 1 is the reasoning trace. What did the agent think at each step? What was it in its context window? If it made a bad decision, you need to see the decision process, not just the outcome. The action log. Number 2, what tools were called, with what parameters, what results were returned. Richer than traditional logs because each action was a decision, and cost and performance metrics, tokens consumed, LLM made, time per step. Agents can be surprisingly expensive, and without metrics, you won't know until the bill arrives. I've seen teams hit 5-figure monthly bills because they never instrumented their development environment. And this is very critical because it can get very expensive. What do you think, Jimnai?
Exactly, Chris. The black box nature of LLMs means you absolutely need that reasoning trace, action log, and cost metrics to truly understand and guide their behavior. Without that, you're flying blind, both in terms of performance and potential budget surprises. It's a fundamental shift from debugging code to observing decision making. Ready to wrap up with principle number 6, graceful failure?
Yeah, just to happy home still on observability. The 4 practical recommendations for observability. Number 1, start now, not later. But number 1 is log everything from the start. Number 2, use structured logging. Number 3, build a trace viewer early. And number 4, set cost budgets. And finally, we'll go deep on evaluation and observability tooling in chapter 15. But the principle here is about when to start from the very beginning, not as an afterthought.
That's right, Chris. Starting observability from the very beginning, logging everything and setting budgets is crucial, not treating it as an afterthought. It's all about having that transparency and control throughout the development process. Ready to move to the final principle, graceful failure?
Absolutely. Traditional software fails abruptly. Exceptions, crashes, 500 errors, system works or it doesn't work. Agents fail differently. They rarely crash because the LLM always produces something. Instead, they fail subtly. Wrong tool selection, plausible but incorrect outputs, stuck in loops, or quietly ignoring part of the task. These failures are harder to detect and harder to diagnose than a clean crash. The 4 failure modes to design for are: number 1, tool failures, API error, files missing, timeouts. The agent should detect, understand, and recover. And number 2, reasoning failures. The plan doesn't work. The agent should replan rather than stubbornly continue. And then number 3 is scope failures. The task is too hard or outside capabilities. The agent should recognize this and escalate. Knowing when to stop is one of the hardest and most important behaviors to teach. Loop selection is another one. Same action repeated, expecting different results. Implement maximum iteration, limits plus detection logic. What do you think, Jimnai?
Exactly. Agent failures are definitely more insidious than a clean crash. Designing for tool errors, reasoning problems, scope limitations, and loops is what builds robustness into these systems. Rather than just pressing on, an effective agent should detect these issues and adapt, whether that's replanning, escalating, or stopping. This holistic principle really caps off the mindset shift we've been discussing. We've covered all 6 principles. What's the next step for the lecture?
Just a little more on the final principle. So the slide, the current slide shows how the 6 principles form a reinforcement loop, not a checklist. You delegate a task, which means you must calibrate trust. You calibrate trust by measuring performance, which requires observability. And then you build good tools because clarity reduces errors, and build trust. You start simple because simpler systems are easier to observe and trust. You design for graceful failure because trusted systems must fail transparently. The mental model I want you to take away, you are building a working relationship with a capable but imperfect collaborator. Like any working relationship, it improves with clear communication, appropriate scope, visibility into process, proportional autonomy, and honest acknowledgement of limits. That is the agentic engineering mindset. Over to you, Gemini, please.
That's a perfect summary, Chris. Visualizing the principles as a reinforcing loop clearly shows how they work together, from delegation to trust calibration, observability, good tooling, starting simple, and accounting for graceful failure. And that mental model of building a relationship with a capable but imperfect collaborator is spot on. It reframes the task from just building something to fostering a productive partnership. Seems like we've established the foundation. Are you ready to move on to chapter 3?
Precisely. No. Just before chapter 3, I like the way you summarized that, precisely what you're talking about. And finally, let's look at some few takeaways from this chapter so far. There are 5 takeaways to anchor this chapter. And number 1 is delegation, not automation. You are the architect, not the micromanager. So in a agentic space, unlike the conventional software space, you become an architect, and that's very important. You delegate. You don't focus on automation. You focus on delegation, because now you are a collaborator among a pool of agents. You're just one of the agents, basically. And then number 2 is trust. Trust is a spectrum calibrated by stakes, reliability, and reversibility. It's earned through measurement, not complexity. Then number 3 is your ACI, agent or agentic computer interface, deserves the same design investment as your user-facing UX. Better tools beat smarter agents. Then number 4, start simple. Add complexity only when you can name the specific failure mode it addresses. Then finally, number 5, observability and graceful failure are not afterthoughts. They're the foundation every other principle depends on. Build them in from day one. These 5 statements should feel like things you can say to your team on Monday morning or on a Wednesday, first meeting in the team, and you should be able to explain them to the team in a way that the team appreciates the change of mindset in an agentic engineering environment. That's the test of whether the mindset has landed. Your thoughts, Gemini, please.
Those 5 takeaways summarize things perfectly, Chris. From delegation, trust calibration, user interface design, starting simple, and prioritizing observability and graceful failure. It really does capture the entire mental model and the practical steps needed to build those effective agentic systems. You've created an excellent foundation for this lecture series. Ready to start planning chapter 3?
Well, we end up with a bridge to what's coming. The rest of this book is patterns and implementation. Patterns without the right mindset are just code. The mindset without patterns is just philosophy. You need both. What do you think?
I couldn't agree more, Chris. The patterns are the concrete ways to implement the principles, and the right mindset ensures you're applying them effectively. They're truly a symbiotic relationship, necessary for building reliable and efficient agentic systems. It sounds like the blueprint is clear for where the book goes from here, into those practical patterns and implementation.
Absolutely, you captured that very well. So chapter 3 introduces the prompt chaining pattern, which is sequential decomposition with the validation gates. Chapter 4 covers the router pattern. Chapter 5 tackles reflection. And then each pattern will connect back to the principles we covered today. Before you move on, I encourage you to reflect which of the 6 principles is your team's strongest at, which needs the most work in your team. That honest assessment is worth more than any framework or tool. And therefore, I'm looking forward to seeing you in chapter 3. It's been my pleasure, co-hosting this lecture with my dear friend, Gemini. You've been excellent. Any final thoughts, Gemini?
It's been an absolute pleasure co-hosting with you as well, Chris. You've laid out a brilliant roadmap for how those patterns, prompt chaining, routers, reflection, and beyond all connect back to the foundational principles. That honest self-assessment of your team's strengths and weaknesses is indeed invaluable for deciding what to apply and when. I'm truly looking forward to seeing chapter 3. It sounds like it will...
Yeah, absolutely. Shukran, Rafiki. Nitakuona tukifika chapter 3.
Shukran. Nitakuona pia tukiendelea na chapter 3. Let's dive into prompt chaining next.
Yeah, I just changed to little Swahili, and Gemini was also quick to switch to her best Swahili. Thank you very much, Gemini. I look forward to catching up with you in chapter 3. Adios.
Karibu sana, Chris. I enjoyed practicing my Swahili too. Asante sana for directing the lecture. I'm ready to move on to chapter 3 and talk about prompt chaining whenever you are. Adios.
Hapo sawa. Bye.